Okay, so we are doing number 9 here, and this says that the solid lies between planes perpendicular to the y-axis at y equals 0 and y equals 2. The cross-section is perpendicular to the x-axis are circular discs with diameters running from the y-axis to the parabola x equals the radical 5 y squared. So let's start with a picture. And if I can find the right screen, here we go. So here's the given graph. And you can see this runs from here to here. This right here, this little kind of, it's like a triangle, but it's got a curve on one side of it. This is what we're revolving around the y-axis. So this area right here, kind of shading it in, pretending. It's not going to let me here on this screen. So this is what we're trying to revolve around. Since we're going on the y-axis, we're going to go where our limits of integration are going to be in this, so 0 to 2. And this is going to be our graph. So we use our disk method here. Not our disk method. I'm jumping ahead to something else. So at this point, they said specifically, they said to use, what did they say to use? Let's go back to the right screen. They said to use circular disks with diameters that are, so each diameter here, not this screen, I have too many screens open. Each diameter goes from here to up here, somehow from here to here. That's what each diameter is going to do. They're going to go from that as we're revolving around the y-axis. So I need to figure out what that area is. So to do that, my area is going to be, well, the area of a circle is pi r squared, right? We learned that back probably years and years ago. So what's our radius? Well, our radius is that graph, our diameter. So let's start here. Diameter, 5y squared. But we want the radius, right? Well, the radius is half the diameter. So this equals the radius. So ax squared is pi 5y squared 2 squared. Okay? Then I can simplify this down. So this is pi. That's going to become a 5/4 y to the 4th. Okay, so this is my a of x, and I'm going to integrate it from 0 to, I already forgot what I have here, right here. 0 to 2. Okay, and this is why we draw the picture. Read this one. 0 to 2, and we're going to use this formula right here. So it's going to be pi 5/4 y to the 4th dy. Now what I'm going to do at this point is I'm going to pull out what I don't need. Kind of, simplify it. So all this can go out front. 5/4 pi 0 to y to the 4th dy. Now this is a nice simple power rule. So 5/4 pi times 1/5 y to the 5th evaluated between 0 and 2. Then at this point, the 0, that's all going to be a 0. So I only really care about this 2 up here. That's nice. So then I have, let's see here, the 2 5s cancel each other out. So I have 1/4 pi 2 to the 5th. Well, 2 to the 5th is 32. 32 divided by 4 is 8. My answer is 8 pi. So the volume, going back here to my picture, the volume, when I take this kind of triangular area and revolve it around the y-axis, the volume is 8 pi. That's what this tells me.